This is the video for the Unit 2 Part C, Solving Problems with Ratios. This goes along with Disaster Prep 6.210, using ratio tables with large quantities. It takes about 40 pounds of olives to make 3 liters of olive oil. Orchard A grew about 2,000 pounds of olives. How many liters of olive oil would this make? So first I highlighted 40 pounds of olives, and all I know is 40 pounds of olives makes 3 liters of olive oil. Now, then it tells me Orchard A grew about 2,000 pounds of olives. How many liters of olive oil would that make? So all I know is I'm comparing the amount of olives with how much olive oil the olives make. So in this picture, you see olives and olive oil made out of olives. So I'm going to make a ratio table, and I'm going to put the olives first. And olives is, the unit is pounds, LB. And I'm comparing olives, the amount of olives, to how much olive oil it makes. And the olive oil unit is in liters, so I wrote L. The first thing I want to do is take the original information at 40 pounds, so 40 goes under olives, 40 pounds of olives makes 3 liters of olive oil. Now that's already filled out for you. So now I'm going to go into the question. Orchard A grew about 2,000 pounds of olives. All I know is if I have 40 pounds of olives, that makes 3 liters. So how many liters would 2,000 pounds of olives make? Now, if I'm looking at this, 40, let's say I'm struggling with thinking of how 40 could turn into 2,000. Well, if I look at the number 4, I know 4 times 5 makes 20, and that helps me get closer to the 2,000, that 2 number in the front. So I would try 40 times 5, and 40 times 5 is 200, because 4 times 5 is 20, add a 0. So 40 times 5 is 200. So you multiply 40 times 5 to get 200. You do the same thing over here. 3 times 5 to get 15. That means if I have 200 pounds of olives, I could make 15 liters of olive oil. Now that I have 200 pounds, I can easily change 200 pounds into 2,000 pounds. So what I'm trying to do is come up with numbers that'll make it easier for me to get to the amount that I want to make. So now to go from 200 to 2,000, just do times 10. And over here times 10. 200 times 10 is 2,000. 15 times 10, 150. So if I have 2,000 pounds of olives, that'll make 150 liters of olive oil. And then that's it. 2,000 pounds will make 150 liters of olive oil. And that's it. Now again, you could always change these into other numbers, but this is pretty easy. Changing it from 40 to 200, or I could even do 40 right into 20 if I wanted to, and that would give me a decimal over here. But to me, this is pretty easy. That's lesson 6 to 10. Now let's move on to 6 to 11. Solving multi-step ratio problems. So in this one, this is also, it took us a few steps, but let's take a look here. Solving multi-step ratio problems, balloon 6 to 11. Red balloons float orange marbles at a ratio of 6 to 4. So I highlighted red balloons, and I highlighted 6 in pink to show that the first number belongs to red balloons, so 6 belongs to red balloons. Red balloons float the orange marbles would be 4. So every 6 red balloons, it would float 4 orange marbles. So in the picture you see 4 marbles here, 6 balloons up here. Question 1. How many marbles can 24 balloons float? So again, I'm comparing balloons to marbles, so I made a ratio table. Balloons goes on top, marbles goes on the bottom. The first number is 6, it belongs to balloons. 4 goes into marbles. Now, how many marbles can 24 balloons float? 24 represents balloons, which is the number that goes on top. So that means I put 24 up here. 6 times what makes 24? 6 times 4. So then I do the same thing at the bottom. 4 times 4 is 16. That means I need 16 marbles to float 24 balloons. Question 2. How many balloons are needed to float 10 marbles? Again, so I'm going to take the information from the original. Balloons to marbles, making a ratio table, balloons to marbles is 6 to 4, so 6 over 4. How about how many balloons are needed to float 10 marbles? So since I'm talking about marbles, that goes on the bottom of the marbles. Now 4 cannot turn to 10, but I do know that 4 can turn into 20, and 20 can turn into 10. Now, I could also change 4 into 2, but here I change 4 into 20. So either way would work. 4 times 5 is 20. 6 times 5 is 30. Then how do you change 20 to 10? Divided by 2. 30 divided by 2 is 15. Now, what I could have, so the answer is 15 balloons. I could also have changed 4 into 2 and then 2 into 10. If I did that, it would be 4 divided by 2 is 2. 6 divided by 2 is 3. And then 2 times 5 is 10. 3 times 5 is 15. So either way would have worked. And now number 3. Here are two students' work for problem 2. Describe each strategy. So we're going to talk about what they did. So Deja actually made a double number line. She did the same thing as what we did in the ratio table. She has balloons on top, marbles on the bottom, and then she started off with 6 balloons, float 4 marbles. She changed 6 into 30, which is what we did. 6 times 5 is 30, 4 times 5 is 20, and then she went from 20 to 10. 20 divided by 2 is 10. 30 divided by 2 is 15. So Deja actually did the same thing that we did. Now, at this time, if you can, what I would like you to do is near Deja's name, put a little smiley face over here. She did the same thing that we did, except she used a double number line. We did a ratio table. Now, Charlie's strategy, Charlie actually found the unit rate over here. He found that 1 marble floats 1.5 balloons. Then he went from 1 marble to 10 marbles times 10. So to find the unit rate, he divided 4 marbles divided by 4 to make 1 marble. 6 divided by 4 is 1.5. And then to go from 1 to 10 times 10 times 10. That's how he found 10 marbles floats 15 balloons.